My name is Johan Kraft. I'm a CEO, CTO and founder of Percepio. Most embedded software is written in C or C++, but these languages does not completely specify the runtime behavior. And the runtime behavior is what ultimately counts, right? The static source code is of course fundamental, but it does not give the full picture, since the runtime behavior also depends on dynamic effects, for instance variations in timing and interference between tasks or threads. Such dynamic effects are emergent properties that are not visible in the source code. To get the full picture, you also need runtime monitoring. There are at least 3 types of runtime monitoring. The most common one is probably application logging, where printf debugging is a prime example. This is very flexible, just insert some print statements and you get a textual log of your application. However, this is often associated with a considerable overhead. Outputting a string of, say, 15 characters over a UART at 115 kilobaud takes about 1 millisecond, which is unacceptably slow in many situations. Moreover, it's often not appreciated to have printf lines all over the code. On the other end of the scale we have instruction trace, where the data is not generated by software but by the processor core. This means essentially zero overhead, but the scope is limited by the hardware implementation. For instance, it's often not possible to record function parameters, return values or local variables. This also requires expensive bulky equipment and you need a processor and a board that supports high-speed trace ports. Moreover, this produces a very large amount of data on low abstraction level that can be difficult to overview and analyze. A middle path is software event tracing. This has the flexibility of application logging, but is much faster, measured in microseconds per event. Moreover, the instrumentation is typically predefined within the RTOS or middleware APIs, so you don't have to insert a lot of printf statements in your code. At Percepio, we currently focus on software event tracing and application logging. Percepio provides visual trace diagnostics, which is not just a tool for runtime monitoring, but a solution for efficiently gaining actionable insights throughout the development process. We combine efficient solutions for runtime monitoring with advanced data processing that actually understands the meaning of the events and builds an OS-aware model of the recorded data. This is made accessible and really nice to use via bespoke data visualization with over 30 interactive views from different perspectives and at different abstraction levels. Tracealyzer is our analysis and visualization tool for trace data. It also provides live real-time recording capability for FreeRTOS, SafeRTOS and MicroC OS 3. It also supports other real-time kernels and operating systems via third-party tracers. It is ideal for system-level debugging and works a bit like a surveillance camera for your embedded software, where you can identify issues in high-level overviews and then zoom in to see specific events in detail to understand the cause of the problem. DevAlert is our new service for IoT devices that allows for direct feedback from customer operation or from field testing regarding runtime errors and other software events of interest. As you know, software is rarely bug-free even at release, and the sooner you can become aware of missed bugs and fix them, perhaps via an over-the-air update, the fewer customers will be affected. If you react and deploy a correction fast enough, most of your customers probably won't be affected or even notice the bug in the first place. DevAlert is a cloud service that provides a DevOps-style feedback loop from the devices back to the developers, and also provides traces for remote diagnostics in Tracealyzer. We provide a reference implementation for AWS, but other cloud vendors can also be supported. You find more information about DevAlert at https://percepio.com/devalert.